This is a condensed version of the Dutch Steamboat lantern build-out, which was done in 10 episodes. The lantern on the left is zinc, followed by a tin plate lantern that has been painted black, 2 red brass lanterns, and 1 Turne Tin lantern. You will see a quick overview on how to build these. A foot shear is used to cut out all straight components, and this is a significant time saver. On pieces that have unusual shapes, a pattern is used and is traced in order to make it simpler to replicate the piece. What is shown here is like the top and bottom of the lanterns. The top of the lantern has a 4-inch hole which is used to vent the gases. This is showing the rough cut of the hole, which is finished with a finer cut. The purpose of the rough cut is to remove most of the material. A finer cut should have not less than 1/4 inch of material to remove. An alternative to this is the use of a ring and circle cutter, which makes this process much quicker. All the components for the Turne Tin lantern are now cut out. You will see the circles, which are used for making the fonts, as well as the top and bottom. Obviously the top has a hole in it, as well as the deflector top. One of the most useful machines in a sheet metal shop is the bar folder. This allows you to bend straight components into any angle configuration that is desired. It also has a gauge setting, so repetitive bending can be done quite easily and simply. In this operation, I'm using the bar folder to bend the back and front of the top lantern to a 90-degree angle. The bar folder cannot be used to form the 2 sides of the lantern. A box and pan brake has to be used. The fingers on the pan brake are set at 7 inches, and this allows a complete closure of the top. Another useful purpose of the bar folder is to adjust the back bar so that instead of a tight 90-degree bend, you get a very open bend which allows the wiring of components. What you're looking at is the top deflector, which has the open bend created by the bar folder. The special purpose machine is setting down the wire so that it has a wired edge, which actually gives strength and beauty to the components. The slip rolls are a very useful tool to make components into circles or partial circles. This is being fed slowly through in order to eliminate a flat spot that would be created if it was just fed directly through for the right radius. The final completed component is a font, which is used to hold the oil burners. When you have wired edges, you cannot use the slip rolls, therefore you have to use mandrels made of steel, wood, or any other component to roll them around. The lantern top is being passed through a swedging machine that adds a decorative swedge as well as a strength component. This is a special purpose machine and these swedges have been custom made. It takes numerous passes to completely set the swedge in place. After the top of the lantern has been swedged, it is placed in the bar folder to turn the front and back down 90 degrees. This also helps straighten the front and back of the lantern. The assembly of all the lantern components are done with solder using a soldering iron or a Bernzomatic torch. The solder is usually 60-40, which is 60% lead and 40% tin. When I assemble the font, I always solder the top from the inside so that you cannot see the solder joint. I install the bottom and solder that from the back side, as that's the only practical way of doing it. On the assembly table, you will see a completed font which has an electrified burner on. This is the standard. You will see 4 of the completed fonts along with the retaining ring, which is used to hold the fonts to the lantern. This contraption is used to position the back, top, and bottom so that they are at right angles and the sides are in the same plane. This is important because when you install the glass, they need to be almost perfect. It is also important to keep in mind the heat from the soldering process will distort the metal, therefore it is required that it be tightly clamped together. The soldering process starts with first filling the gap with solder. Once this is accomplished, you go over the solder on several passes to smooth it and to fill any holes that remain. The columns are now attached to the lantern box structure and soldered in place. Prior to doing this, it is again checked to make sure that the lantern is still square. This is a completed lantern box. The next step is to install the inner gas deflector, which is soldered in place. After this step is done, the outer gas deflector is installed in place. Again, it's important to clamp the pieces firmly together so the heat doesn't distort the metal. When assembling brass components, a technique that I used often involves the tinning of both surfaces or applying a thin layer of tin. Then the parts are clamped together and heated with a propane torch, which melts the tin into a nice fused bond. The advantage of this is you get a very clean solder joint. The lantern door consists of 3 channels that are folded in the bar folder along with 1 straight section on the bottom. A piece of masonite, which is slightly thicker than the glass, is used as the frame to weld them together to ensure a section that is flat and has the proper dimensions. The closure clasps are made out of 1/8 inch diameter brazing rod or stainless steel to match the color of the lantern. In order to bend these, it is required to heat them up to cherry red, and the hairpin bend, or the first 180-degree bend, is bent around a piece of flat plate which is 1/4 inch in diameter. The next bend is made in a machinist vise with using the 1/4 inch spacer to maintain the proper spacing, and the rods are bent down 90 degrees. It is required to get these clasps in the same plane so they fit properly. Each lantern requires 9 hinges, therefore they are mass produced by first cutting out the hinges at 1-inch increments. Then they are folded up in a bar folder to create an open joint similar to what we would use when we wire an edge. The wiring machine has been outfitted with rolls that are 1/8 of an inch wide. This is to accommodate the hinge rods and closure clips that are also 1/8 of an inch. The next step involves using a wire set-down machine to close the sheet metal around the wire. The door is centered in the door opening and clamped in place. The individual hinges are tack soldered into place. The installation of the hinges is a tedious process. It requires each hinge to be individually bent and cut to length to meet the configuration of the lantern. I use a bending tool that gives me the proper radius configuration to bend the 3/16 brazing rod. I have to use it twice to get 280-degree bends to create the handle. Because of the spring back, the handle will not completely close, therefore I have to put it in a machinist vise and heat it with a torch to anneal and or soften the metal. In order to make the lantern handle hold down, I developed a process that I refer to as counterintuitive bending. One of the requirements was to get nice clean lines where the handle attaches. Once the handle stock is cut out, I roll it to the configuration of the lantern top. Then I go to the bar folder and fold it into a channel configuration. I then take this and bend it over a 1/4-inch rod in order to create the proper opening for the 3/16 handle. When I start bending this, I will have a configuration that looks like a flying W, and as I keep bending it further and further, it will end up with the same configuration as the lantern. This is obviously a fairly manual process, but it does the trick. The lantern handles are then centered on the top of the lantern and soldered in place. Often I put a protective wire grid on lanterns, which is principally for decorative purposes. They're made out of 1/8-inch brazing rod, which is bent at 90 degrees. They are then put in a wooden jig to hold the configuration and soldered together. I cut small snippets of wire at approximately the same length and melt them into balls. The grid wires are then placed over the balls and heated. The balls attach in a Hershey kiss form to the grid wires. Once this step is completed, the grid will be placed on the lantern with a weight to hold it in place. A moderate amount of heat will be applied to the solder to solder it to the lantern. Care needs to be taken not to put too much heat in place, otherwise the miniature Hershey kisses will be distorted. Cutting mirrors and glass is an essential skill in building lanterns. Some of the glass that is hand blown or hand rolled can be a little more challenging to work with because the thickness is not uniform and the temper is not similar. Once the glass is scored, I take the back end of the glass cutter and put it under the score line and press down, and it snaps. When all the soldering is completed on the lantern, the next step prior to varnishing is to polish the lanterns. This can be time-consuming because of all the nooks and crannies that you have to get into, but it is really the most important part to bring out the luster and beauty of all the different metals. I use a slow-drying polyurethane spar varnish to varnish the lanterns. I varnish them starting with the inside and working through all the inside components, and then I start on the outside components. The spray has to be done with multiple short blasts held at 12 inches or more away from the lantern. I go over the lantern 3 or 4 times, and when I have a desirable wetting pattern, it will appear slightly milky, but this will go away when it dries out. If you overspray, you will get runs, which often result in you having to completely strip the lantern and repolish. If you underspray, you get a sandpapery look finish, which is also not desirable. This is now the final assembly. I am installing the wiring, which will have a cord coming in at the bottom and a on and off rotary switch on the top of the lantern. I will install the second piece of glass, which is held in place by the retaining clips. Then I will install the reflective mirrors, which hide the electrical components and also reflect the light in a chevron pattern. To complete the inside of the lantern, I then screw the burner onto the font and place it in its retaining ring. I then install the glass in the door frames, holding it in place with the retaining clips. The door is then attached to the lantern with the hinge pins, and this completes the assembly. All 5 lanterns have been completed, and they all have slight variances. The first lantern on the left is zinc, and when zinc is polished, it has a pewter look. The second lantern is tin plate, which has been painted black, and the accents are the grid as well as the handles. The third lantern is red brass, and it is 5 inches taller than the rest of the lanterns. The fourth lantern is red brass also, and is the standard height. And the fifth lantern is Turne Tin, which has a dull gray finish. 3 of the lanterns have Belco hand-blown glass, and the 2 silver-looking lanterns have hand-rolled glass, which is more uniform in thickness. What you have seen is an overview of the 10 episodes of the build-out of the Dutch Steamboat lantern. You are encouraged to go to my YouTube channel, colonialmetalsmithing.youtube.com.